Lorentz series, lesson 4. We are going to do some more examples based on this series. So this example is, obtain the Taylor's or Laurent series which represents the function fz equal to z square minus 1 over z plus 2 into z plus 3 in the regions mod z less than 2 and mod z lying between 2 and 3. Right? So here fz is equal to z square minus 1 over z plus 2 into z plus 3. Now you will observe that in this function, the power of the numerator is equal to the power of the denominator. If this happens, we cannot expand, right? So we need the power of the numerator to be less than the power of the denominator. If you say that this fz is equal to z square minus 1, if you solve the denominator, you are getting z square plus 5z plus 6. Now you will see that the power of the numerator and denominator are same, right? So what we have to do is, see, in the numerator I am having z square. In the denominator also I am having z square. Let's adjust some terms with respect to the denominator, right? So in the numerator, I just add and subtract this 5z plus 6. I'm adding and subtracting 5z plus 6. Z square plus 5z plus 6. If you separate, then you will get this to be equal to 1 minus this will be 5z minus 7. Or if you take the minus sign common, then you will be having 5z plus 7 over z square plus 5z plus 6. Right? Now make the denominator in factors. So this will be fz is equal to 1 minus 5z plus 7. On factorization, I will get z plus 2, z plus 3. Right? So this is equal to, now separate them as partial fractions. This will be z plus 2 and z plus 3. Yes, tell me. If I put z plus 2 is equal to 0, what do I get? Z equal to minus 2. Now put the value of z equal to minus 2 in the above 5z plus 7 over z plus 3. Excluding this z plus 2, you will get minus 3, yes, over 1, right? Now z plus 3. If you put z plus 3 is equal to 0, you will get z equal to minus 3. Put this value z equal to minus 3 in 5z plus 7 over z plus 2. Except z plus 3, you will get plus 8. Right? So your final fz is coming out to be 1. If you open the bracket, this will be 1 plus 3 over z plus 2 minus 8 over z plus 3. So clearly fz is analytic in the given regions and has Laurent series representation. Now we can expand them, but with the conditions which is given to us according to that only, right? So the first part is for mod z less than 2 and mod of z by 2 less than 1. Now mod z less than 2, this is your first part which is given to us. From here, because I always need something less than 1, right? So Should I take 2 to the denominator of mod z, or I take mod z to be in the denominator of 2? Because I need less than 1 sign. So it's better we take the 2 in the denominator so that I can get mod z by 2 less than 1, right? So fz is equal to 1 plus 3 over z plus 2 minus 8 over z plus 3. Now, because I'm having mod z by 2 less than 1, so I need this mod z by 2 in the denominator of 3. So what should I take common from the denominator, z or 2? If I take z common, then I will be having 2 by z in the denominator. But I need mod z by 2. So I have to take 2 common. One plus z by 2. Very clear? Alright. Next. 8 over z plus 3. Now I also know that if mod of z by 2 is less than 1, then obviously mod of z by 3 is also less than 1, because it is less than or equal to mod z by 2. Further, it is less than 1. So mod of z by 3 is finally less than 1. So again I need mod z by 3. So I should take 3 common. I hope this is very clear to you. Next. Now we have to take this denominator in the numerator as their inverses and expand the series. So this is equal to 1 plus 3 by 2, 1 plus z by 2 inverse minus 8 over 3, 1 plus z by 3 inverse, which is equal to 1 plus 3 by 2. I am expanding this 1 plus z by 2 inverse, but in the summation form. You can check my remarks in the very first video of the Laurent series, the second video, right? Check the remarks. The formula is given over there. So this is equal to this minus 8 over 3 summation n going from 0 to infinity minus 1 the power n z over 3 the power n. And whenever you expand in the bracket, you must write that this expansion hold as z over 3 is less than z over 2, which is further less than 1. Then only you can expand this series. So this is equal to, if you sum up, you take the summation common and you will get n going from 0 to infinity. This is 3 over 2 n plus 1 minus 8 over 3, just adding the powers of 2 and 3, minus 1 the power n, z the power n. Here the power is 2 raised to the power n, and if you take 2 inside, this will be 2 raised to the power n plus 1. Similarly, 3 raised to the power n plus 1 powers are added. Now for the second part, mod z is lying between 2 and 3. What does this mean? This means again we need something which is less than 1. From 2 less than mod z, what I get the condition? I will get the condition as 2 over mod z less than 1, right? And from here, mod z less than 3, I should take mod z over 3 less than 1. Is it clear? Because I need less than 1, right? So now fz is 1 plus 3 over z plus 2 minus 8 over z plus 3. Now for the second term, 3 over z plus 2. What should I take common? Because I need 2 over z. I need 2 over z. So I should take z common. So I take z common and I will be getting 1 plus 2 over z. Right? Now for the third term, I need z over 3. So what should I take common? I need z by 3. So I take 3 common. 1 plus z by 3. Just interchanging the terms. Right? Now again we have to take this denominator as their inverses in the numerator and expand the series. So this is equal to 1 plus 3 by z, 1 plus 2 by z inverse minus 8 over 3, 1 plus z over 3 inverse, which is equal to 1 plus 3 by z, yes, summation n going from 0 to infinity, minus 1 the power n, 2 over z the power n, minus 8 over 3, summation n going from 0 to infinity, minus 1 the power n, z over 3 the power n. Now collecting the summation. So this will be 1 plus 3 over z. No, it's not. Just write like this only. Summation n going from 0 to infinity, minus 1 the power n. This will be 2 the power n over z the power n. Then 8 over 3, summation n going from 0 to infinity, minus 1 the power n, z the power n over 3 the power n. You can also leave it here only, right? You can also leave up to here only. Now the next example. Obtain the Taylor's or Laurent series which represent the function fz is equal to 1 over z squared plus 1 into z plus 2. Now here I am having the term z square plus 1, right? When first mod z less than 1 and mod z lying between 1 and 2. Okay, let's make our fz first. Now fz is equal to 1 over z squared plus 1 into z plus 2. Now how should I separate this? Partial fractions. This is equal to z squared plus 1 and z plus 2. First we solve this z plus 2. Put z plus 2 equal to 0, you will get z equal to minus 2. Put z equal to minus 2 in the fz, excluding the z plus 2 factor. So this will be 1 over, yes, 5. Right? Now about this. Z square plus 1. Put z square plus 1 equal to 0, you will get z square equal to minus 1. Right? Now where should I put z square equal to minus 1 in fz? I am having in fz, I am having 1 over z plus 2 and I should exclude z square plus 1. I have to put z square equal to minus 1 in this. How should I put? There is only z. So we need to rationalize this, right? So this is z minus 2 over z plus 2. Just rationalize it. So this will be z minus 2 over z square minus 4. Z minus 2. So this will be z square minus 4 and then you will get z minus 2 over. Now you put z square equal to minus 1 over here. We need not put the value for z which is present in the numerator. No. So this will be, we only have to put z square equal to minus 1. What we are getting here is z square equal to minus 1. We just have to put the value of z square, not z. So this will be minus 1 minus 4, which gives you z minus 2 over minus 5. So here this will be z minus 2 over minus 5. Is that clear? Is that clear? Okay. So in such cases, you just need to rationalize the terms and put the value. So you will get 1 over 5, 1 over z plus 2 minus z minus 2 over z square plus 1. This is the required fz. Now the first part, for mod z less than 1. Yes, this is 1 over 5. Now I am having mod z less than 1, which means I should take z common or 2 common? Yes, I should take 2 common. So this will be 1 by 2, 1 plus z by 2. See, if z mod z is less than 1, then obviously z by 2 is also less than 1. Yes? For the second term, I'm having z minus 2 over z square plus 1. There is need not to be taken anything common because I'm already having 1 plus z square, and for that I'm having mod z less than 1. So I can easily expand this with this condition. Okay, next, take their inverses in the numerator. So this is 1 over 5 1 by 2, 1 plus z by 2 inverse minus z minus 2 as it is, and 1 plus z square inverse, which is equal to 1 over 5 1 by 2 minus 1 the power n summation n going from 0 to infinity, and z by 2 the power n. That's it. Minus z minus 2 into summation n going from 0 to infinity minus 1 the power n z the power 2n. It is z squared the power n. And finally, I'm having 1 by 5 1 by 2 summation n 0 to infinity. This is minus 1 the power n z the power n over 2 the power n minus z minus 2 summation n going from 0 to infinity minus 1 the power n z the power 2n. That's it. Easy? Very easy. We just have to keep in mind the condition less than 1. What we write, what we fraction with z, so that I can get that less than 1 sign, right? For the second part, I'm having mod z lying between 1 and 2. Now I need the sign less than 1. For that, from first 2, I should take mod z in the denominator so that I can get 1 by z less than 1. And for the next mod z less than 2, I should take 2 in the denominator so that I can get z by 2 less than 1. Right? We just need to remember this, less than 1. And then this is an exercise for you. According to these two conditions, take what is to be taken outside from the denominator and then take the factor to the numerator as its inverse and expand. Right? This is the answer for the second part. Just an exercise for you. And I'm giving you some more exercises. Just try this on your own. Represent the function fz is equal to 4z plus 3 over z into z minus 3 into z plus 2 in the Laurent series. First, within mod z equal to 1. Now, what is the meaning of within mod z equal to 1? That means what you have given. You have given your z lying between 0, 1. Right? So, for this, the condition is given to you as mod z less than 1. Right? Now, for the first part, you are having fz to be equal to this, and I have also separated them in partial fractions for you, right? Now, this is the solution which is given to you for the first part. Just try this. First term is as it is. For the second term, I'm having mod z less than 1. So, what should I take common? I should take 2 common, because if z is less than 1, then obviously z by 2 is also less than 1. So for the second term I should take 2 common, and for the third term I should take 3 common, because again z over 3 is less than z by 2, which is further less than 1. So for the first part, take 2 common and 3 common from the denominator. Second, in the analysis region between mod z equal to 2 and mod z equal to 3. Now analysis is given to you, which means you have given mod z lying between 2 and 3. What are the conditions you will get from here? 2 over mod z less than 1, and from mod z less than 3 I should get mod z by 3 less than 1. So now, first term is as it is. For the second term, what should I take common? I need 2 by z. So, take z common. From the third term, I need z by 3. So, take 3 common. Right? Third, exterior to mod z equal to 3, which means mod z is greater than 3. So, I should get what condition from here? Sorry. Because I need something less than 1. So, 3 over mod z less than 1. Right? Take mod z to the denominator of the 3. So, you will get 3 over mod z less than 1. Now, first term is as it is. For the second term, what should I take common? I need z to be in the denominator. Yes. So, I should take z common. Right? So that I will get 2 by z in the denominator. And obviously, if 3 by mod z is less than 1, then 2 by mod z is also less than 1. For the third part, I need 3 by z. So I should take z common, so that I will be having in the denominator 1 minus 3 over mod z. Right? So take z common. Then solve further. This is the solution for the first part. This is the solution for the second part, and this is the solution for the third part. Right? Okay. Next, one more example for you. As an exercise, find the Taylor series or Laurent series of fz equal to 1 over z minus 1 into z minus 3 in the powers of z. In the region, these 3 regions are given to you. So, fz is equal to 1 over z minus 1 into z minus 3. I separated them into parts. And for the first part, I am having mod z less than 1. So, check. Mod z less than 1. So, I should take 3 common from here, right? So, this will be mod z by 3 less than 1. If mod z is less than 1, obviously, mod z by 3 less than equal to mod z further less than 1. So, I should take 3 common, because I need z to remain in the numerator in this fraction, right? So for the second one, 1 minus z, no need to take anything common, it's simple. You are having mod z less than 1, just expand this. Second one, mod z lying between 1 and 3. Okay. For this, what are the conditions I'm having? For 1 less than mod z, I'm having 1 over mod z less than 1. And from the second, mod z less than 3, I will have mod z by 3 less than 1. So for the first part, I need z by 3. So I take 3 common so that I get z by 3 in the denominator, right? For the second, I need 1 by z. So I should take z common so that I will get 1 by z in the denominator, right? So for the second part, take 3 outside and z outside, right? Just try this, solve this and tally your answers. So next time also we are going to do some more examples with other types, right? Thank you for watching this video. Hope you enjoy this video and it's very clear to, everything is very clear to you, right? Alright, have a good day. Goodbye.